Okay, so the easiest kind of projectiles to do at an angle is ones that have a symmetric path, which means they start and end at the same height, okay? So when you're making your list, there's just a couple things to note about this, right? So you'll have some kind of a V naught, okay, which will split to a V naught X and a V naught Y, okay? And remember, the V naught X stays the same the whole way, all right? So the V naught Y is going to get slower and slower as you move, Vy, okay? At the very top, right, we have been saying in free fall, like that's where the ball like sort of stops or turns around, okay? The Vy at the top is 0, but it still has the X velocity at the top, okay? So in the Y direction, it has that stoppage point at the top, but in the X direction, it does not because it's just still moving, okay? And then as it goes here, the V naught X will stay the same, and then your Vy will get bigger, and then your Vy will be bigger here, okay? All right, so this is a perfectly symmetric path, all right? So notice that your V naught Y over here is going to be the same as your VFY over here, okay? Because it's a symmetric path, if there's no air resistance and all that, blah, 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 okay? All right, so your V naught Y is going to equal your V final Y, right? Because whatever amount it loses in speed on the way up, it gains on the way down, okay? And then at the Y direction, it's 0 at the top there, all right? A couple other things to note about a symmetric path. Okay, this is half the time, and then this is the total time, right? And it's a clean break, right? So if you look at just the first half of the path, right? If it takes like 2 seconds to get to the halfway, it's going to take 2 seconds to get back. So you can just solve it for the half time and then double it. All right, that's a symmetric path. What else do I want to say about the symmetric path? Okay, you can look at these problems. I would either look at half trip. Okay, this would be where you would want the V Fy to be 0 at the top. This you would use if you wanted to know the maximum height, right? Because if they ask for the maximum height, that would be here. Okay, so you'd have to use the half time for that. What else might you find there? And they sometimes might tricky ask you the speed at the top, and you're going to want to say that it's stopped, but it's not, right? Because it still has V naught X. That's probably it for half trip. Then the other thing you'll do is you might look at the whole trip. Okay, so if you're looking at the whole trip, that would be looking at the total time. This would be looking at half time up here. Total time. Your delta X would be the total. Sometimes they call this the range. Okay, that would be a whole time thing when you're looking at the delta X. Okay, a handy thing to know is what's the delta Y for the whole trip? 0. Okay, and yes, you just plug in a 0, and yes, it works. You don't have to worry about, but what if it went? No, it doesn't matter. It started at the ground, it ended at the ground, the delta Y is 0. That's a handy thing to know, okay? And then you could find like the V final Y as it hits the ground, right? That would be a whole trip thing. And I think that's about it, right? So you just have to look and just be careful whether you're looking at half the trip or the whole trip when you're doing a horizontal. When you're doing an angle launch projectile. All right, I think that's it.